right, so today we're diving into something pretty mind-blowing. Google's new quantum computing chip, Willow.
Yeah.
You sent us some really fascinating stuff to dig into.
Mm-hmm.
We've got a blog post right from Google's quantum AI team, and then a bunch of news articles reacting to the announcement.
It's been getting a lot of attention.
Yeah, you want to know what makes Willow so special, how it works, and what it could mean for, well, pretty much everything.
Yeah, for sure. And it's even sparked some excitement from some pretty big names.
Like who?
Well, even Elon Musk chimed in.
Really?
Just tweeted, wow, when he heard about it.
Wow, is right? I mean, the headlines are calling this a quantum leap forward.
For sure.
But before we get ahead of ourselves, let's break it down.
Yeah, let's get back to the basics.
What is Willow, and why is everyone making such a fuss over it?
Willow is a quantum computing chip.
Yeah.
And what makes it so remarkable is that it represents a major step forward in a field that has frankly faced a lot of skepticism.
Okay, so I remember hearing about quantum computers a few years ago, and the potential always seemed enormous, but it also felt very theoretical. What's changed? What makes Willow such a breakthrough?
So there are two key milestones that Willow hits.
Okay.
The first is error correction. You see, quantum computers use these things called qubits,
Right.
which are like the bits in a regular computer, but way more complex.
Uh-huh.
Think of a regular bit like a light switch.
Okay.
It's either on or off 1 or 0.
Got it.
A qubit can be in both states at the same time,
Whoa.
which is mind-boggling,
It is.
but also makes them very sensitive to any kind of interference.
So it's kind of like trying to solve a complex equation on a chalkboard while someone's shaking it back and forth?
Exactly. That's what makes building larger, more powerful quantum computers so difficult.
Right.
But Willow is the first to achieve something called below-threshold error correction.
Okay.
It's basically like having noise-canceling headphones for your quantum computer. As you add more qubits, which you need for more power, the error rate actually goes down.
So more power, less noise.
Exactly.
Got it. What's the second big breakthrough?
Performance? They ran Willow through a test called random circuit sampling,
Okay.
which is a problem designed to be brutally hard for classical computers.
So like our everyday computers.
Yeah, Willow solved it in less than 5 minutes. The world's fastest supercomputer would take something like 10 septillion years to do the same thing.
Okay, that's not just a difference in speed. That's practically another dimension.
It is.
No wonder people are calling this a game changer.
It is, but it's important to understand that Willow is more than just a speed demon.
Okay.
Google has made some really smart design choices that allow it to adapt and optimize its performance in real time.
So it's not just powerful, it's also incredibly efficient. But how did they actually build this thing? What's going on inside the Willow chip? It all comes down to those qubits, right?
Yeah, those qubits, they're not like the simple on-off switches in our everyday computers. Imagine them more like tiny spinning coins that can be heads, tails, or both at the same time.
Wow.
That's the power of quantum mechanics. And Google has found a way to control and connect these qubits with incredible precision.
So they can actually like manipulate these tiny spinning coins to do calculations.
Exactly.
That's amazing. And where are they even making these things?
They've actually built a dedicated facility for making these chips in Santa Barbara.
Wow.
It's one of just a handful in the world,
Really?
which shows you how cutting edge this technology is.
So we've geeked out a little bit on the tech specs.
A little bit, yeah.
But now let's get to the exciting part.
Okay.
What can Willow actually do in the real world? What problems can it solve that our current computers can't even touch?
That's the million-dollar question. The potential applications are truly vast.
Like what?
Well, one area where Willow could have a huge impact is drug discovery.
Okay, so how would it actually help with developing new drugs?
Imagine trying to design a drug that targets a specific protein involved in a disease. Right now, simulating how that drug interacts with the protein at an atomic level is incredibly difficult for classical computers.
It's just too much information.
Way too complex.
Yeah.
But a quantum computer like Willow could do this with ease, allowing scientists to test and refine drug candidates virtually.
So like before they even start?
Yeah, before even stepping foot in a lab.
That's incredible.
It really is.
It's like having a virtual laboratory where you can experiment with countless possibilities in an instant.
Absolutely.
That could totally revolutionize how new drugs are developed. What else can it do?
Material science is another exciting area.
Okay.
Willow could help us design materials with completely new properties.
Like what kind of properties?
Think about superconductors that work at room temperature or ultra-strong lightweight alloys for aerospace.
Wow. So we're talking about things that could completely change industries.
Absolutely, from energy to transportation.
Okay, so from saving lives to making us all a little richer.
Potentially, yeah.
Willow's got it covered.
Yeah.
What about artificial intelligence? I've heard quantum computers could like supercharge AI in ways we can't even imagine yet.
You're right. AI is another area where Willow could have a profound impact. Quantum computers could accelerate machine learning algorithms,
Right.
leading to AI that's faster, more efficient, and capable of solving problems that are currently intractable for even the most advanced systems.
So it's almost like we're talking about creating a new type of intelligence.
It's certainly a possibility, and it raises a lot of interesting questions about the future of AI.
Like what?
And how we interact with these increasingly intelligent systems. But it's important to remember that while the potential is vast, we're still in the early days of this technology.
Right. It's not quite ready for prime time yet.
Not quite.
But this all sounds incredible. I'm also wondering about like the downsides. Are there any risks we should be aware of?
Well, one concern with quantum computers is the potential for breaking encryption.
Oh, is all our data going to be vulnerable, like bank accounts and stuff?
Well, not necessarily. Thankfully, researchers are already working on new encryption methods called post-quantum cryptography
Okay.
that are resistant to attacks from quantum computers.
So they're like staying one step ahead.
Exactly. It's a bit of a race against time, but the good news is that we're aware of the potential risk,
Okay.
and we're working to mitigate it.
Phew, that's a relief. Are there any other potential downsides?
Well, the truth is quantum computing is still in its early stages.
Right.
Willow is a huge step forward,
For sure.
but there are still significant challenges to overcome. One of the biggest is moving beyond these theoretical benchmarks and figuring out how to use quantum computers to solve real-world problems.
Right. It can't just be theoretical.
Right. It has to be practical and cost-effective.
Yeah, it's not just about building a super fast computer.
Exactly.
It's about figuring out how to harness that power to actually make a difference.
Exactly. Google's next challenge is to find those killer apps for quantum computing.
Like, what would a killer app even be?
Well, applications that are both beyond the capability of classical computers
Right.
and genuinely useful for solving real-world problems.
Yeah, that makes sense. It really feels like we're on the verge of something revolutionary here.
It really does.
But like you said, it's still early days.
Yeah, it's going to be fascinating to see where it goes from here.
I'm curious, what did you think about Sundar Pichai's response to Elon Musk's wow?
Oh, yeah.
He mentioned putting a quantum cluster in space.
It definitely captures the sense of possibilities surrounding this technology.
Right.
Imagine a network of quantum computers orbiting the Earth, collaborating to solve some of humanity's grandest challenges.
A quantum internet in space. That's next level. Okay,
Wow.
listener, we've thrown out a lot of big ideas.
Yeah, we have.
But what do you think?
Yeah. What are you thinking out there?
What are the most exciting possibilities that come to mind when you think about widely accessible quantum computing? What problem would you want to solve with it?
It's a question worth pondering. And this deep dive is really just the beginning. We've only scratched the surface of this fascinating topic.
And if you have a burning question, a topic you're dying to explore, send us your sources and we'll take the plunge together.
We'd love to hear from you.
Until then, keep exploring, keep questioning, and keep diving deep.
Keep diving deep.
If this tech tutorial was helpful, please like this video and subscribe to our channel. For more detail, you can visit our blog website www.evergreentechtips.com.